Welcome to The Explainer. Today, we're going to break down how these big, complex systems actually get built. We're mapping out the entire story of a system's life, from just a simple idea all the way to a fully functioning tool that people use every day. So, let's just jump right in with a question that probably keeps a lot of project managers up at night. You've seen the headlines, right? A huge new software launch gets delayed. Again. A government IT project goes billions, with a B, over budget. Or maybe a new app just doesn't work the way it was supposed to. Why on earth does this happen so often?
Well, the thing is, the problem usually isn't about bad ideas or untalented people, it's chaos. Imagine trying to drive across the country with no map, no GPS, and nobody in the car can even agree on the final destination. That's what it's like. Without that clear roadmap, even the most brilliant project is just going to get lost.
So how do you fight that chaos? Well, that's where something called the System Development Lifecycle, or SDLC, comes in. Think of it as the master blueprint for building any information system. It's this formal, structured, problem-solving process that guides you all the way from, hey, we have a problem, to, hey, we have a working system that solves it, and then keeps it running.
Okay, so before you can even think about writing a single line of code, you've got to know who's on the team. And that team has a massive decision to make right off the bat. So let's meet the key players you'll find on pretty much any systems development project. First up to bat, you've got your systems professionals. These are your tech experts, the architects, the engineers, the construction crew for our project. They're the ones who are going to analyze the problem and physically build the solution.
But, and this is so important, they can't just build in a vacuum. That's why the end users are just as critical. I mean, these are the folks who are actually going to live and work in the house we're building. If you don't listen to them, you might build an absolutely beautiful system that solves the wrong problem. Total waste, right?
And then, kind of overseeing the whole thing, you have the stakeholders. Think of them as the city planners and the building inspectors. They're the ones making sure the project actually lines up with the big picture business goals and, follows all the rules. Okay, the team's all here. Now what? Well, they immediately hit their first huge fork in the road. Is it better to build something totally unique, a custom-designed system from the ground up, or should they just go out and buy a pre-built commercial software package that's basically ready to go? Now, this is where it gets really interesting, because it's all about trade-offs. If you look at this, building in-house gives you perfect customization. I mean, it's tailor-made. But the downside? It costs a lot more, and it takes forever. On the other hand, commercial software, it's way faster to get up and running, it's usually cheaper upfront, but you might have to change how you do business to fit the software. Plus, you're totally dependent on that vendor for updates and support. All right, so the team knows who they are, and they have a general direction: build or buy. Now it's time to actually lay the foundation. We're diving into the blueprint phases of the SDLC, where the whole project really starts to take shape. And here it is, the whole 8-phase journey laid out for us. You can see how it starts really big picture, super high level, and then it just drills down, getting more and more specific as we go, from analyzing the problem to designing the solution, building it, launching it, and then keeping it alive.
Everything kicks off right here in phase 1, system planning. And the main goal here is to make sure this project isn't just some cool idea floating in space. It has to connect directly to the company's long-term business plan. We have to ask, does this thing we're about to spend a ton of money on actually help the company get where it wants to go in the next 3 to 5 years? Next up, phase 2, we get into system analysis. I like to think of this as the detective phase. The analysts are on the case. They're digging into the current system, interviewing people, gathering facts, all to figure out what the real problem is and to find exactly what this new system has to do. But there's a real trap here. You have to understand the old system, sure, but there's a danger of getting stuck in what's called the physical tar pit. That's when you get so bogged down in the details of the old paper forms and the way things are currently done that you just end up building a faster digital version of an old broken process. You haven't actually made anything better. Okay, so the planning's done, the analysis is complete, the blueprint is there. Time to swap the detective hat for a hard hat. We're moving from designing on paper to actually constructing this thing. And in phase 3, we hit another one of those big decision points. Is the team going to use a structured design approach, basically creating the whole system from scratch? Or are they going to go with an object-oriented approach, building the system from reusable components, kind of like how a car is assembled from standard parts like an engine and wheels? This brings us to a super critical reality check. Phase 4. Before anyone starts spending the big bucks, the team does a detailed feasibility study. They have to ask the really tough questions. Do we actually have the technology for this? Can we really afford it? Is it even legal? Will our employees be able to use it? And can we finish it on time? This step is absolutely crucial.
So, once the project gets the green light from that feasibility check, we roll right into phases 5 and 6, which are basically two sides of the same coin. The conceptual design gets turned into a super detailed technical instruction manual. Then the programmers take that manual, pick the right language, and start actually writing and testing the code that brings it all to life. The system is coded. It's tested. It's a real thing. But wait, we are not done yet, not even close. Building it is only half the battle. Now comes the really scary part, launching it out into the real world and making sure it has a long, happy life. This is Phase 7, System Implementation. A huge decision here is how you go live. Do you go cold turkey, turn off the old one Friday, turn on the new one Monday? It's like ripping off a Band-Aid. Fast, but man, it can hurt if something goes wrong. Or do you phase it in, department by department? Or the safest but most expensive way, run both systems at the same time for a while. And at last, we've arrived at the final phase, system maintenance. And here's the kicker. This is usually the longest and most expensive part of the whole shebang. This is the endless process of fixing bugs, making improvements, and just generally keeping the system healthy and useful for years and years.
So what's the big takeaway here? Well, the SDLC gives us this incredibly valuable logical framework for turning huge, complex ideas into reality. But it also leaves us with this really cool question for the world we live in now. With everything in the cloud and constant updates getting pushed to our phones, is a system's life ever really over? Or is it just in a state of constant, endless evolution? Something to think about.